Okay, we're going to start our our last unit of the semester, and it's about evolution. Okay, the big guy in evolution is Charles Darwin. He wrote a book called The Origin of Species, and he's the one that has, survival of the fittest, where, the animals that have changed, that have adapted to the environment are the ones that are going to survive and pass on their genes and so on. Okay, the origin of species focused on the attention of the great diversity of organisms. Okay, he saw that there was, the same species of bird had different beaks, different feet, different, all kinds of stuff like that. So that's where he based it on. No, he noted that the current species are descendants of ancestral species, so they're different than the ones that they came from. Okay, so he called it evolution. And really, what evolution is, descent. As you have more and more offspring, they're modified. Okay, and so evolution is really a pattern and a process. Okay, there's a pattern based on the environment and a process that occurs over, several generations to change so that they don't look like their ancestors did. There's some characteristics obviously the same, but things change. Okay, so what happened was with Darwin, if his ideas, he has very deep historical roots. He was, a rich kid, and he was very well educated, and he had all these ideas. And if you look here, here's kind of a timeline of when things happened and what he was looking at. Darwin did a lot of traveling, and he went to a lot of remote islands, and he saw a lot of different varieties, and this is where he got a lot of his ideas from. But you can see his timeline. This isn't a big deal, but you can see some of the ideas, some of the things that came across. One of the guys, Lamarck, was one of the guys that had a hypothesis of evolution, and I think we'll talk about more about him later. He's had some kind of goofy ideas. But anyway, Darwin studied all this stuff and came up with his own ideas. Okay. The first guy that came up with like this origin of species was Aristotle. This was way back, the BC days, the toga days and the wreaths on their head. But he arranged things. He called it scala naturae, or the nature of species. You can even see I don't know if you read the Bible, but it has some species in there. The original ones were designed by God and therefore were perfect. So, why did they change? Well, of course they changed because of the environment. Okay, Linnaeus, that's the guy I was talking about before. Carlos Linnaeus interpreted the adaptations. Okay, and he actually came up with maps to show the changes that had occurred. And he's also the one that came up with the way of naming organisms. One of your assignments way in the beginning was I had you give me the name of like 5 different things. We started kingdom and phylum and goes down the order. But then he also, when you got to the end, the genus and species are the scientific name of something. He was the founder of that. He actually started with all of them. But when he started, there was only 2 groups. There was animals and plants. We've since added, algae, protista, and fungus, and so on. But he was the one that got it all going, and he's the one that came up with that system for classifying organisms. Okay, and again, he's the one that came up with format. Like our people's scientific name is Homo sapien. This word Homo is the genus, and sapien is our species, and they're always written so the genus is capitalized and the species is not. Okay, so Darwin's looking at all this information. He's getting the idea from fossils, because we get a lot of evolution ideas from fossils. They're the remains or the traces, and they can look at those and see how they looked, many years past. They'll date the sedimentary rock in which they were found in, and they'll find them in layers. Okay, when they do digs, when they do archaeological digs, they'll find top layers, and they'll keep going down, and the layers are called strata. And you're going to find different fossils in the layers because these are different time zones. Okay, these were all laid down, and then there was life going on, and then you had another layer of sediment put down, and so on. So when they study, obviously these fossils are the youngest, and then they get older as you go down. Okay, so the study of the fossils is called paleontology. If you become a paleontologist, you're a geologist. And George Cuvier, he's the one that kind of the father of it, if you want to call it that. He speculated the boundaries. So he knew that there was some sort of catastrophic event that occurred between the boundaries. Like with the extinction of the dinosaurs, they know that there was this big, basically probably a meteorite hit and put so much dust in the air that it choked out everything. And so they had that layer. So, they knew that was an extinction. And so they had catastrophic events in between the layers. And so that's what you look at when you're looking at your fossils. Okay. Another famous geologist is James Hutton. He did a lot of work again with the changes in the surface of the earth. And so he was more of like, the faults and the cracks and all that. But he, the information that he came up with, the continuous actions and what happens with them, is what he came up with many, many years ago is still held true today. So, and his ideas of how things moved and changed helped Darwin a lot with his thinking. Okay, so you wouldn't think a geologist would help a biologist so much, but he really did because of basically what was going on with the fossils and that kind of stuff. Okay, Lamarck, he's kind of one of my faves because this guy was really funny. Lamarck hypothesized, he said species evolve through the use and disuse of body parts, and they inherit what they want. If you want to put this in layman's term, if you want to have a child that has curly hair and you don't have curly hair, if you get a perm, the child will be born with curly hair. That's kind of how Lamarck's theory plays out if you want to think of it in normal body terms. He just thought, well, if you want something, you'll just pass it on. Not that you had to worry about genes or chromosomes or anything. Just, yeah. So if I want my child to have curly hair, if I get a perm, then my child will have curly hair. I've seen cartoons about his ideas where a guy got a tattoo on his arm. So, his child should be born with a tattoo on his arm. That's kind of his theory. Kind of crazy, I know. But, at the time, it was a long time ago. People went, oh, okay, if you say so. Okay, his mechanisms were definitely unsupported by evidence. There was no proof of what he said. Okay, so, Darwin saw his ideas too and just went, eh. So now he started exploring, looking at all these islands and stuff. And so that gave him some ideas of what wasn't happening. So he started doing research. Again, Darwin was all about nature. He was a true biologist. And he did a lot of reading. He was a smart dude. So he started looking at these ideas. He was going to be a doctor, but he didn't do very well. He dropped out of medicine, and then he started doing theology at Cambridge. But again, he was a big time thinker, so maybe that worked better. Once he graduated, then he took a position as a naturalist. Again, remember, he was really into biology. He went with a guy named Robert Fitzgerald. He was a captain, and they were going on a voyage around the world, 5 years. It was on a boat called the Beagle, and he went to many places on this. So even though he didn't get paid anything, he did a lot of note-taking, got a lot of information. So in the long run, it was, for the best, I guess. In his voyages, he collected species of a lot of animals from South America, plants, trees, all kinds of stuff. And then he started looking at fossils, and he noticed that the living species from the same region, they all resembled, they were similar from other regions. I mean, why do fossils in the South resemble fossils that were taken from, millions of miles north? Not millions, but you know what I mean. So he was like, what's going on here? So, and then when he was in Chile, they had an earthquake. So then they had a whole bunch of new rocks exposed. I mean, this was like nirvana if you're really into fossils, I guess. I mean, not that an earthquake is a good thing, but it was a good thing for him. Okay, so he started looking at these fossils, and again, he had these principles of geology so that he knew that the lower ones, the older fossils, were down below, and the younger as he went up. And when they got shifted, he could figure out how old they were. So he used the principles of geology to figure out which fossils were from which area. And then his big thing, the thing that really set him, was when he went to the Galapagos Islands. They're west of South America, and he spent a lot of time there. And that's where he got a lot of his ideas, because they're really isolated. So he's like, why are these species that colonized, they had special characteristics that they didn't have anywhere else, but they were, like I said, they were an isolated population, and they had really different kind of characteristics that helped him survive in the Galapagos. Okay, here's his whole trip. If you want to look, this is quite a I mean, think about traveling on a boat, a ship like this, I should say ship, right? And all the places he went. But he liked to spend a lot of time down in here, whatever. But he went all these places and he collected. Here's his Galapagos Islands. They're right up here. This was his big spot. This is where he got a lot of information from. Okay, because these islands are so isolated. He got a lot of information for his books. I should say book. His book is The Origin of Species, and he wrote some other ones, but that's the book that, put him on top. But again, he looked at his observations, and once he was on these islands and he saw the adaptations that they had made, he knew that somehow organisms adapt to their environment. Okay, so new species could be evolved. They'd be closely related, but because of the circumstances in which they had to make adaptations, if they didn't, they died. So from studies made during his voyage, he concluded that what happened, his big thing was the Galapagos finches. And there was a lot of changes in them, and he documented them all. And that's really where he got most of his ideas from, is these birds. Okay, so he started labeling them. They're all finches, but this one was a cactus eater, this one was an insect eater, and this was a seed eater. And if you look at their beaks, they're adapted to whatever they eat. Their feet were a little different too. So he's like, they made these adaptations so that they could be whatever they fed on. That's what they were best for. So he wrote an essay on natural selection, and he said this was the mechanism on which we modified. As generations went on and on and on, they were modified, and it was modified because of the environment in which they live. Okay. This process, again, the actual definition of natural selection is a process in which individuals with favorable inherited traits are more likely to survive and reproduce. Okay, if you think about it, the birds that had the beak that could peck into the cactus are going to get more food, and they're going to reproduce. The ones that can't get are probably going to starve and die. And that's what he based this natural selection on. It's the process. The ones that are more adapted to the environment are the ones that are going to reproduce. And so pretty soon you're going to have a new generation with all of them are going to have that special beak. And the ones that don't are going to die. Okay. In 1858, so he got a manuscript from another guy named Wallace, who helped him. They developed the theory of natural selection, similar to Darwin. So the two of them started kind of working together to get, hash it out to make sure it looked good. Okay. So because Russell was kind of on the same path as him, and it was like, do I work with him? You know what? I got to get my origin, because he had wrote an essay about it, but he didn't really publish it yet. But now he was a little worried because Russell is kind of coming up with, or Wallace, excuse me. Wallace is kind of coming up with the same ideas. So he quickly got his out there, because I don't know if I talked about other scientific things, like Rosalind Franklin. She got ousted by the other guys because they put their stuff out before she did. Another example would be the periodic table. There was two guys that were working on it, Mendeleev and Lothar, and Mendeleev got his information out first, so he's the one that get credit for it. So I think Darwin was worried about that, so he published his and got it out there. Okay, so in The Origin of Species, in this book that he wrote, there was three things. Okay, the unity of life, the diversity of life, and a match between the organism and their environment. And this is the big thing when you're talking about natural selection. Okay. We have a lot of diversity, we know that. But the thing is, when he noticed, especially like I said with the birds, they adapt to the environment. They change their beaks, and again, it might be something that happened with one and it was an adaptation that worked better. So again, those organisms are going to be the ones that produce more babies, and pretty soon you're going to have all the organisms with that characteristic. Okay. So that's descent with modification. He never used the word evolution. He always said descent with modification. I think evolution was added later, and that was in the first edition of his Origin of Species. He just always said descent with modification, which it kind of describes everything there. The phrase descent with modification summarized his perception. Okay, what happens? They modify and it's passed on. Okay, and the phase refers to the view that all organisms are related through descent from an ancestor that lived in a remote past. So everything was passed down from an organism, and it just keeps going generation to generation. And I think we are done so far with this because I'm out of time.